Socket programming. Socket. Socket is the endpoint. There's a touching point where there is an adapter. Okay. A specific connection can be identified by not only IP address, then it can come to the destination. But along the network hierarchy, from physical layer to application layer, well, from top application presentation layer, and there is a session layer, and network and data link layer. Session layer, when you enter the system, then you will have one session connection. Okay. As you enter into that session, then you need to be in a specific open port number. You are not yet in any specific application, but you need to be in that port that is connect point. Of course, application also touches linked to that point. That point is called port. So at one end you have application. Let's say this is a socket. Then your application is connected to here, and this is entire desk here. This is your server or host. Okay, and somebody wants to connect to you, then there are multiple ports available. So this application is already connected to. Connected to means this application open a port and waiting somebody's to come. So somebody from outside come here. When he comes here, he will receive a session ID. The session ID is assigned by a port. So in order to get a session ID, then you need to have a specific port number, not only IP. If you have IP, then IP comes into this desk. But this desk has a lot of port. So if you specify a specific port, then you can come into this port. Once you get in this port, then your host, your system, assigned a session ID. At this point, this guy also knows who you are. Who you are means this guy does not know specific you, but this guy knows you, where you are from, IP. If this guy asks a login name and password, then your login name also knows, your password also checked. So that once you pass all that authentication process, then you will get a session ID, so that you are connected to this port. So through this port, at the other side there is an application running. At your side, you have some request. Okay, there's a port. So primitive to implement a high-level networking interface is a remote procedure call. When I learned network programming about 20 years ago, we have to deal with remote procedure calls a lot. Okay, now we are so much high level of programming, so interface is already done. Not much that you need to do. As we set up server and application today, therefore application can talk to the server. Okay, then you will know more clearly. This is a conceptual view of a socket. So okay, yeah. Up here we have user application layer. In the network architecture, we have presentation layer and session layer, network layer, data link layer, physical layer. Some of the layers are specified, but here some more specifically we can get into the socket layer and transport layer. Yeah, there is a transport layer. In the transport layer, between transport layer and application layer, there is a socket layer. So this is somehow where we need to work on. Your application has your application needs to call. Thing is this: your application cannot talk to external devices at all. Socket or hardware, socket port, Ethernet port or USB port, they are all socket. Application program, your application itself cannot talk to, because you do not have privileges. You do not touch any such programs in your programming. The language that you are using at your application program is very, very high level. For example, send to, or bind, receive from. Those are the functions, very, very high level. And those functions needs to talk to the kernel level of your operating systems. We will learn that when it comes to operating systems. But your application is at user side. The system side, there is another big program packages running, which we call operating systems. Okay. Operating systems can deal with all kinds of details, all scheduling, all management, all security issues needs to be handled by that operating systems. Examples of operating systems is Linux, right? It's very popular and robust, or Windows. And then there is the operating system has also some layer, the core layer, where there is the major functions already built. We call that system core. Okay, that guy can handle all external devices. Network is part of external device. Print, that is external device. All the sockets, that is external devices. Your program cannot talk to them. It is prevented. What you should do, although you do not, we do not realize, but internally, if you say, for example, in Java program or in Python, if you say print, okay, and you can print to the real physical printer, right? Not standard output, which is your monitor. Monitor is also external device. It has nothing to do with your CPU. So when you say print, the high-level programming, automatically it works for you, right? But internally, when you do print, but it should connect it to the system call, which is an operating system. And in the operating system, there is a very, very sophisticated modules available, which are developed by your system developer, Linux or Windows, and which has highest privileges. So what it does is that you do not have that highest privileges, right? You are just an end user. Although you do not have administrator privileges, in your programs, in your type, you can do print something. Print, when you say print in your programming, it should touch the operating systems where there is a very, very high level, sensitive, very strong functions needs to be executed, which is already developed. Once it is executed, then it is a highest privileges. Those are all things can be handled by operating systems. From low-level request, your operating systems provide high privilege functions to be executed. Unless otherwise, your program cannot do anything, right? Similarly, in your application program, you activate, there's all request, bind, send to, receive from. They're all request function to be requested to the operating system, a specific operating system that can handle socket layer procedures, okay, where there is a hardware also. Buffered data and the physical socket, they're all hardware related issues. By the way, therefore, there are a lot of security holes. Your application program with the low privileges, but in order to get the job done, that low-level function calls needs to activate highest privilege functions. Once the highest privilege function is executed, then at that point, the owner is the highest privileged owner, which is administrator owner or root authority. Your program is a low level. Low level means in privileges. But it allows to call and activate the functions which requires the highest privileges. So sometimes if you interrupt abruptly while this highest privilege function is executed, then abruptly you can get the highest privileges authorities. Okay, that is also possible.
So that's a security flaw?
That's a security false. Or it's not false. It is provided in order to make the job done. But it is possible only physically if you are on that system. For example, server is running here. Therefore, protection physical server is the first way that we need to maintained for security purpose. If somebody is sitting on your lap server physically, then hackers can get the highest privileges very quickly. I can do that too. Therefore, these days, they don't allow you to access. They allow you to access only from remotely. Then, from the remote, interrupt. No, in real high-level application programmer, even does not need to know about this socket programming. But for network programming, without knowing this socket programming, there's nothing that you can do all the way down to the physical layer, right? Even for the packet analysis, like a transport layer, session layer, network layer, there are a lot the information that you can capture or you can attach it and pack so that the packet can be transmitted. So what socket programmer can do here, socket programmer can do, should take care of everything about this communication from that application layer to somewhere here socket layer. That is what socket programmers needs to play. So socket programmer needs to be somewhere here. If you see here, the operating systems, all the built-in functions, we call that usually system call. System calls functions are available here. So what socket programmer needs to do is to call the system calls, invoke the system calls, so that system calls will be able to be executed. But the owner and user of the system calls is the root users, highest privilege users. We are not, right? But we can request. All right. That's what we need to do. So, little more formal way of socket description is in this way. Socket is an interface between application and network. So your application, if your application needs to talk to external devices, network is also external devices, external entity, then your application is to create a socket. When you learn, for example, the primitive level or beginner's level of Java programming, then usually sometimes we teach that, but not, I've never taught here at Mercy, but yeah, network needs to be discussed so that we open the sockets. We need to use the applications of network, net in Java, for example, so that your Java programs can talk to the program at another machine. As far as there is a IP address and socket number assigned, then Java, those two Javas can talk each other. The socket type dictates the style of communication. So we can set, for example, connection-oriented communication or connectionless communications. So your application needs to set one or the other. So some connection may be reliable, of course, depending upon the protocol that we choose. Some connections can be reliable. Once configured the application, then application can pass. Once configured the network or sockets, then your application pass data to the socket if you want to send the data to the socket. Then after that, network architecture can take care of that. At the other end, there's another application. Then that application receives the data from the sockets. That's what we want to practice today. There are two types of sockets available. Well, the more than two, but we're going to, those two are very common. Socket stream and socket datagram, dgram. So socket stream and socket dgram can be different in this way. So socket stream is so-called TCP. Socket DRAM is so-called UDP. The data that when you send the data, depending upon the type of data or application, depending upon the application, choose one or the other. For example, email. If you send the email, then email program, emailer is the application program that can handle your emails. That choose TCP. But if you download music, video, then that video server choose UDP protocol.
Because it's faster? Is that the reason the connectionless is faster?
That is part of that. And another thing is that you don't need to, for example, video, you do not need to make sure that all the packets of the video delivered completely, because the size is usually very big. So, and there's number one reason. Another reason is that even if some drops, it's not really a big issue at the receiver side, right? But email, on the other hand, if any packets, let's say you have long emails, all text. If that email drops part of the text, then that is a big problem, right? So in that case, TCP or socket stream protocol makes sure that all the data arrives at the destination properly, completely.
So the TCP that sends information?
TCP is a protocol, some specification.
Okay, so what does it specifically, what's its job? What does it specifically do?
TCP, the packet, if you see the head information,
like a video or an email or something.
Head information, it has all the detailed information. If that packet is lost, then according to that specification, we know that, this guy is packet number, for example, 13 out of 26. That's dropped, so that we need to we can check and maintain the completeness and completeness accurately. So all detailed information should be packed into a packet so that at the both sender side and receiver side, they can make sure that did I receive all? Did I send all? If there is any missing, then request again. Who requests? Not you, not application, but operating systems, network managers. Program will request it so that it can make sure that all the original size of the data completely, properly delivered. On the other hand, the UDP. UDP is very, very small. You will see that, the specification. Very light way of specification, therefore only something needed, something essential data sets are packed. So there's we don't need to, because we don't need to re-request it. So we don't need to pack that information. So make it light. But usually we need to send the big data, so we keep sending it. At the receiver side, even if part of those packets are lost, still that is no big deal. When you watch a video, if there's some blur or some quick transition, still will be okay, right? When you listen music, if there is some skips, still okay, right?
Okay.
It's not really a big problem.
And that's because of the TCP?
Because of UDP.
Oh, that's
a UDP. Yeah.
Okay.
So with TCP, it doesn't happen like that. With TCP, is
Make sure completely arrive.
so there are no skips, no blurs, because everything is there,
Yeah.
and you know if it's
Mhm.
And
If there is a network physical problem, then at the sender side, application program bounce to the user by saying that, hey, your email bounced. Your email is not delivered. So it's a full service.
so
Although receiver side does not know, right? Because it didn't. At the receiver side, if it is not complete, then application program does not tell you because it is not complete. And also they know that if it is not complete, eventually they will resend it. Okay? So that is a protocol.
So these are all connected to like a socket? Is that what we're talking about? We're talking about like socket, not like
Socket is the first interface. You missed the first session. Here's an outward. This is inside. So you have an application program running. So your application program opens socket. Like you need to open your door so that through that door anyone can come in and going out. Right? That's the interface. So that is a socket. So you have to open. IP address is the address to your home. Okay? But there's no way that you can get in. Which door that you want to use? Right? Sometimes you can open windows only. All the doors locked. Whoever comes in my home, you need to use the windows. Let's say like that. Okay? Then you have to use that window. Right? If you want to open the back door near your kitchen, so whoever wants to deliver kitchen material, you have to open this door, not the front door. Then that guy needs to come in that. So, in order for your application program to talk to another application, then those two application program needs to share not only IP address, but also the port number. Port number. Anything that we can handle port number or that interface is called the socket programming. So socket programmer is the highest sophisticated programmer. If you know the socket programming, definitely you know everything. You can handle, you can program anything that you want. So, okay. Because I don't see my mouse, so I click that. Sock stream, therefore, that is reliable because it makes sure that deliver quality. Dgram, that is unreliable. This is in order guaranteed. Everything should be in order. For example, email, then it should be in order. Dgram, no order guarantees, which means it doesn't mean that the mix them. It doesn't mean mix them. It means it doesn't check the order by order. If some piece is dropped, still okay. For example, packet number 0, 1, 2, 3, number 4 dropped, then next one is 5. So 5 will be the next. In that way, that is not ordered. Sock stream, that is connection oriented. So in order to send the email completely, properly, then during it is sending, it should be connected. Otherwise, will lose. For example, here, okay, in this diagram, from this is your application, okay? So you want to send the data, because the size of the data is big. Not only big, but even small, very, very small, tiny, small data sets, it cannot be only one packet to be sent out. It should be some control packet needs to be sent before the real payload packet sent out. And at the end, there should be also another packet, say, acknowledgement. So all such different control packets together with the payload packets eventually transmitted. So we have a packet number 1, 2, and 3 from this application through a designated socket. Then this socket and this destination, there is a physical connection. During that time, it is a very, very short time, like a millisecond. But that time period, it is connected. It's not shared. But in reality, there's some other programs. This physical line, okay, from here to that, there's a physical line, right? So internet, for example, there are a lot of sharings available. But this socket is designated to this application. So this is a bidirectional. On the other hand, UDP, from the application program, we have the ordered packet list. So those packets come in the socket, and then this socket can send, it's not a specific order, but anyway, that packet's going out from that socket, but some of those are arrived, but not all. This guy dropped, this guy is somewhere, right? This is the UDP case. So in real programming, this is what we are going to do. We can build the server application and the client application. Okay. So we build two applications, okay, server application and client application. Server application needs to rely more on system calls. Your server needs to be ready by create sockets, and then that socket needs to bind with your IP address, specific IP address and port number. Once they are bound, then your server needs to wait and listen. Right? Listen means listen to the sockets if there is any incoming call. Meanwhile, this client program also needs to do socket and bind, but this guy doesn't need to listen. If this client wants to request some service from the server, then user connect to request to the server. So server keep listening. So when it comes to some connection request, then server now decide whether accept that request or reject, deny, right? So at this point, if a server denies multiple times, then we call that denial over services. That's another type of attack, right? Denial over services. But presumably, this server accepted. Okay. Once it is accepted, then acknowledge. Hey, I'm ready. This guy says. So that acknowledgement came here. Then this guy, client, now is ready to request. So request needs to be written and sent out. Then that request is read by the server, and then in order to return the data needs to be written and then send it back. Then this client read that the message from the server. So we keep doing that. Okay. So at the end, either server side or client side, doesn't matter. Either client side or server side can close the connection. Then if client close the connection, then client application is closed. But at the server side, server assumes there will be multiple applications to request, right? So still we leave the server on, and the server still continue to listen to the client request. If server close, then we call that server is down. So there is no service at all until the server gets back on. Question.
So it's about the other slide, the UDP and TCP.
Mm-hmm.
So why do we still use the UDP if it has all those problems? Why don't we just stick to TCP?
TCP is internet killer. If we allow TCP only, then we cannot enjoy all the videos, because there are tons of users who wants to see, for example, news video. Okay, CNN, ABC, NBC from your laptop or home digital TV sets also uses this, right? Then a lot of a bottleneck, because there is a lot of checking between server and client. That's extra, right? Even if we send the one packet size data, we need to send so many other control packets needs to be shared between server and clients. That is TCP. UDP much simpler, so that we can reduce the traffic. And also the types of data that we use from the internet, not all the same, right? Some email, then we want to make sure that I receive complete email. Do you really care if you do not receive any, a couple of video clips not delivered? Think about that. Think about that. The video. If you see the video in one second video, how many frames are delivered? Frame means how many pictures. Video is nothing but a sequence of frames, I mean real still pictures. Okay, how many pictures are delivered in order to see 1 second video? 30 frames. 30 frames in the internet. But analog, long time ago, analog video, only 16. Because we cannot recognize any what is that? Any like one motion to another motion.
Transition?
Yeah, abrupt transition. Yeah, abrupt transition. We cannot our human eyes cannot recognize the abrupt transition if it transit 1/16th second. 1/16th second. We cannot recognize 1/16, which means if we send the 16 frames, then we see that they're all there's a movie. It is a movie. Okay, so analog the videos, I think that creates 24. Yeah, 24 frames, not 16, because our eyes can. If it serves us 15 frames per second, then we recognize it. Somehow, some sensitive guys can, I don't feel good. So, think about that. Video clips, digital, 30 frames per second. 30 frames per second. Assume that we drop half, 50%. Then 15 frames per second. Like me, if those who are not sensitive, then we don't see it. It is a continuous object. So I feel good. Even if 50% of the frames dropped. So we don't need, so diagram is perfect for video service. Audio, same thing. I'm not sure. Audio is a continuous.
I have a question. So does this work with also like telephones and cell phones, or just computers? The socket diagram.
Computer. Yeah, not the current telephone. Yes,
Oh,
current
okay.
telephone has a computer. All right. Socket eye view of the internet. So we have multiple computers. Mercy.edu, we have a lot of computers. CNN.com has one computer. And we have scysecure.org, there's another computer. What is scysecure.org? There's our server, our center server. Where did you learn?
I just took a guess.
You have a good guess. Have you been in there?
No.
Then I will.
Wait, so why does CNN why is it just,
No, my exaggeration. My exaggeration for Mercy.edu. Mercy.edu has more computer. Is that true? Than CNN?
I don't think so.
Me neither.
Because CNN is like,
That's right.
yeah. I think CNN has much more.
Scicecure.org. This is our server, right? I'm going to extend this a little further, but I didn't have enough time. But watch this. This is a good web server that I made. The cybersecurity competition. I'm not sure have you seen this. This is this user interactive. If you move this slide bar, then background is changed. So what user can do, right? For example, remember that cyber security competition? I wanted to prepare that for next year. Every spring semester, we start. Okay, first half of the spring semester. Anyone can join, right? So March 26th, that was the date that we did the kickoff meetings. We have met till the day before fall semester began. We met continually every Saturday during summer also. So during that time, I made this. So you can also enter.
So this is for all the groups that joined, or the groups, or just the group that won?
Anyone who wants to come. For example, Mercy, then here's Mercy together with Dr. John Yoon. And if you move your mouse here, then you can see the team member, Team A, Team B. If you click this, then you can see what they are doing. Team B continually did more and more. This is Team B. So you see Chris, James, Alan Wegener. He joined the first few sessions, but he left. But anyway, this is the web. Okay. Back here, so each host machine has IP address. IP address. Scicecure.org, I'm not sure, but it has 172 dot, let's assume 21 dot 5 dot 10, and Mercy.edu has also some, right? How can you know? There are a lot of ways that you can check the IP address for a particular. This is a nickname, right? This is a nickname. Real address to this server is this IP. And the physical location has nothing to do with this IP. Physical location. Which means by knowing this IP address, if it is registered, then we can, I mean, there's some record, so we can verify, oh, this is registered in New York or California or Japan, China. We can tell, but that is a registration site. It doesn't mean that it is physically located at that place. So IP address is just IP address. And an IP address should be registered and purchased. Where can you buy IP address?
Domain, the domain
Domain server is this. You can buy name. There is a domain. Domain name server. This is a name server. IP address itself needs to be purchased separately or together with the domain name. So IP address, IP number should be purchased from telephone company.
Internet service provider.
Yeah, internet service provider. So Verizon or Optimum. So our site secure.org, that IP number was purchased from Optimum. And once you purchase that IP number, then you need to rely on the domain name server, which is owned by many companies, right? GoDaddy.com or so many others. But we use the GoDaddy.com, and I purchased the sitesecure.org about 10 years ago. Only one time paid by our department, all paid by my credit card because that is owned by me.
How much is that? How much does it cost?
Name itself?
Yeah, for each year.
Name, I think $15 or 20, 25. Yeah, per year.
Per year.
Every year it charges automatically because when I purchased sitesecure.org, I think it is a good name, right? Simple and good name.
We're going to cite the more charge.
Which one?
We're going to cite the more charge.
No, just name.
Oh, just
There's a name. The name only.
Okay.
That name can connect it to any IP address. Okay. While we do not have this specific server, then I connect it to some other servers. Now we connect it back to our server here.
The Mercy, EDU?
Yeah, here in this room. Yeah, that one. No, not EDU.
Oh, okay.
It's different. EDU is different.
Okay.
EDU is here. Okay? So they are now binding together. This is owned by me. This is owned by the department. So owner is different. Right? Owner of this IP number and owner of this name are not necessarily the same like us, but two different entities can bind together, can be bound.
So another name can be connected to that IP address.
That is a good name. Of course. You are smart. So not only this, we can add more and more. For example, Ellen.com. You buy Ellen.com. Okay? You pay and Ellen.com available. And then Ellen comes to me and says, hey, can I hook my name to your server? That IP? Then you can send it to that IP. So whoever comes in Ellen.com, then it comes to the same material, sitesecure.org.
What happens if there's like a lot of traffic? Is there...
If there's a lot of traffic, then congestion.
Yeah.
Simple.
Yeah.
So let's say Allen.org is going to use that same IP address.
Same IP address,
Okay. And then
but same material. So
yes,
why he needs to keep Ellen.com? You can make all of your names and hook to sitesecure.org. Then sitesecure.org become popular. For example, whitehouse.gov, if that link to our server, then all over the world, if they type whitehouse.gov, then comes into ours. Is it? I think Ellen.com is already owned by someone else. Already created, right? So Allen is one of popular names. So these days, if you, for example, not if your name is not popular, then your name, last name or first name only, or first name and last name all together already registered. Try. My names or any combination of my name already registered. Something not registered is the last top domain level, top level domain. For example, not .com, not .org, .net. They are all popular. But these days there's some other top level domain, which is .us. .us is .us is more available. So your name .us, then probably at this point available. If you want to buy, then you can buy .us. I mean, that is a minimum, the minimum rate. If you want to, for example, what is your Wagner? Wagner.com. If you want to buy that, then if it is owned by someone else, then you can purchase it from that person. For example, ABC News, okay? ABC.com, then ABC.com is not owned by ABC News broadcasting company. It's owned by someone, person.
TV station?
Yeah, TV station. Try ABC.com, then it's owned by someone else.
Or something like
It should be abcnews.com. Probably they try to negotiate.
No,
ABC.
They
Huh?
bought it. They bought it and it redirects to their site.
Is that right? So it is not. It is not. This is someone else. Look at this. This is not ABC.
ABC Go. It's like their thing works that we can watch their shows.
Oh yeah, abcgo.com. Yeah, this is.
It redirects to their website. I think they pulled the Google and bought all like the
Right.
similar name websites. That way they don't get people trying to.
Or
scam.
Fox.com. Right, Fox.com. Then maybe owned by someone else. It's a Fox News. Okay. I saw some famous broadcaster company's name, so owned by person. So they add some others at the end. But anyway. Okay, here, when a packet arrives at a host, so packets, for example, somebody from CNN tried to access sitesecure.org through this domain name, which is a nickname. You don't need to memorize this IP address in number, right? It's not really clear. I do not even remember the IP address in number. Only sitesecure.org. So this guy comes here from CNN. Then if this guy comes in here to see our web page, then there is a socket. Port number needs to be specified. Port number right now is 80. Okay. Ports. Each host has 65,000 ports available. 65,000. Some ports are reserved for specific application. For example, 2021 FTP, 22 is a secure shell, SSH, 23 telnet, 80 HTTP, that is our side secure, and 443, that is HTTPS for secure HTTP. When you create, which we will do today, then you can create a socket, and you need to bind to IP address and socket. Although we are doing that in one machine, one PC, that's what we will do, right? This is one PC, your laptop. This guy, this is a server. This guy is client. Because this guy open a designated port, this guy open another port, so that we have more than one client. And port. Each application, this is one of the applications. So each application designates a specific port. So port 1, port 2, and port 3. This is his own port. So this guy, this client, try to access the port 1, and this guy tries to access port 1 also. Okay. Then this server send back the result through that port. So that's an analogy. So bind function associate with bind and reserves a port for use by the socket. So there's a function called the bind. So bind function takes some information about status, socket ID, address, port, size, and the two types of protocols, and for each protocol it has its own specific description. So socket bind all together, and then server usually listen. Okay, so usually we need to import the socket, from socket. It's the import. So from the input socket package, we have a socket, the family of the sockets, and then type of protocols. Those things needs to be specified. For example, create socket, then AF innet and sock DRAM. These are all the reserved word. You cannot define this. This is a word that you simply use. And after that, you have to bind socket, once the socket object is created, then you need to call bind function to bind. This is a port number, and this is the IP address. This IP address is not the IP address of you. This IP address is the IP address that you want to open. So if you leave it blank, which means anyone can come to me. If you specify that 127.0.0.1, then only within your local program. Okay, so you usually will leave it open. And then while true, your server needs to receive 1024 is every time the size of the data. So every time I want to pick that size, and then I can call it data and address. So receive from that function returns two pieces of data. So first one is data and second one is the address. So those two pieces of data assigned to data and address. So that address is used here, and data is used here. Okay. And then client side, similarly, we have to create an object of socket and also bind. Here in bind, and port, this is a bind of my address, and this is IP that if I want to open, then I can use this. I can specify rather than 0 or some others. That's fine. And then this is the older version, so that we have to have parentheses. This and then we can simply check if the socket name or host name, for example, what is a host? So we can display as many information as we can. All those information, those functions are available here in this socket module. So we will take a look at that socket module a little later. And of course we have to specify server. So this client needs to specify a specific server name and then IP. This IP should be the same as this IP that is open. Okay. And then send the data to the server, and then if server send back to me, then we can receive from this. If you look at the server side, server send back to me here. When this server receives the data, that data is changed to the uppercase. When you send, we send, for example, hello, mercy, all small, but server in this program change it to the uppercase. So back to the client side, we will see if it is returned. If it is, the message that I send to server really arrived at the server side and convert to the case and back to me. So that is a kind of test that we can do. So what I will do, all the same. Okay, so get familiar with the socket. Start from that socket.html web page. So if you go there, then you will see this web page. Okay. That yeah. I want you to take a look at this. So we'll take what time is around 10 o'clock. So we'll take 15 minutes. Meanwhile, I want you to read some of this. So when you come back, then we need to read some of the functions associated with the socket module. You need to get familiar with that, and after that we need to do some programming. Okay? All right, let's take a look at the web page here. Where am I? Okay, here. Oops. Without knowing API, it is so-called API, right? Application Programming Interface, or you can call this library, whichever convenient to you. So socket, there's a low-level network interface. We have a socket of families that you need to choose. If you see here, AF underscore Unix, or AF INET family. Usually we use this in the Windows. AF INET 6, this is for another kind of family. So you need to read all those families of the sockets. You need to use a the designated family name. For example, AF Bluetooth. If you want to talk to specific Bluetooth communication, then you need to choose that family. Okay, and then there is an exception. So socket error, timeout, and this is the family names: AF Unix, AF INET, INET 6, and this is the protocol name. Sock stream, sock DRAM, sock row. Sock row, for example, if you want to sniff the packets from your network interface card, then rather than using any other stream or DRAM, of course, those are not the protocol that you want to access when you want to sniff the network packets, right? So you need to use that protocol, sock row. And then functions that we can use here. For example, socket is a module. This module, well, actually this is an object of the class called the socket. So you can call it, say, S or SOC or SOCKET, whatever you want. There's an object. That objects can invoke a function. So first function is a socket. So by having that socket, that your socket is created. So you need to choose a family, which is the first arguments, and type. This is protocol type. So sock stream or sock underscore row, and then proto. You don't need to if you want to. If you want to, you can do, but and file number you can specify also. And sock pair create connection from FD. From FD means FD integer returns by the file sockets file method build the socket object from the result. Address family, socket type, and protocol number are as for the socket function above. And from share socket type. Other functions, these other functions are useful for you to test. Get address info by giving host name and port. And there is an example here, socket dot get address info. This is the address and this port number, okay, so that you can testify that. Or get FNDN, so full qualified domain name, you can get that. Or get host by name, sending host. Get host by name, EX, get host name. If you do this, get host name, you do not need to specify any input arguments. Okay, then you can see the host name, and having that host name, then you can send it back here, host name. So get name info, get proto by name, protocol, get serve by name. And then socket objects has another functions. These are the functions that are very, very important for us to set up the server and clients. So accept is the function, so that server needs to accept the request from clients. This is the function that we use. Bind, of course, this is very, very important, so that we need to put here address. So when you do bind, as we looked at in the slide, if there is a bind from the server, then you do not need to restrict. You could, but in our example, then you need to make it blank. But you have to designate a specific port number, so that through that port, the messages can be listened by you, server. And then close, connect, get sock name, get timeout, listen. This is also important function should be called by the server. This function enables a server to accept connections if backlog is specified. If you specify anything here, then it must be at least 0, which means number 5, for example, that is greater than 0. If it is lower than 0, then it's set to 0. Makefile receive. So receive from. This is the size of buffer. So at each time, the size of that specified will be read by either client or the server. Receive from or receive, both are good. If we use receive from, then it receives data from the socket, and return value is a pair. See here, pair by bytes and address. So first component is the data, and second component is the address, which is not the case here. RECV. RECV from returns two data sets. Send or send all, send to, those are the functions that you can use to send the message. So for example, send to, then this function sends data to the socket from your application. So you send the data to the sockets, and from these sockets, there's a network manager handles, right? Sends data to the socket. Socket should not be connected to a remote socket, since the destination socket is specified the address. So it should not necessarily continually connected to the client or the server. It is managed by operating systems, network manager. Okay, and then there is an example. Internet 4, which is the one that we are using. So this is a server program. This is a client program. Okay. So we can do it similar to this. So what we will do now, I'm going to close slide. Okay. Instead, let's open up Piezo. Control N, therefore I will have a new. I'm going to close all. Okay, let's try some of those. This is server, right? So we'll do a little bit of similar to that. So import to socket. So we can do from socket import everything. What we need to do is we need to use socket and AF underscore init, that is the family. And the protocol that we are going to use for socket creation is sock SOCK stream, which means TCP protocol will be used. This is, by doing so, it is created, but not specific objects that we assigned it to, so we need to assign it to S. So S is an object of socket that we create with that family, with that protocol. After that, we need to bind to a specific socket, which is a port number, but I want to open to all, so I don't need to specify any IP address, but socket number or port number, what number that you want to use. It should be over 2,000, below 65,000. So whichever you want. 54321. Okay, so by this time, socket is created, and that is binds the specific socket here. Okay, port number. And then I want my socket listen. Okay, so let's put that number listen 1. Let's figure out what that means. Here, a function socket listen backlog. You don't need to, but it should be greater than 1, greater than 0. Okay. It specifies the number of unaccepted connections that the system will allow before refusing new connections. If not specified, the default reasonable value is chosen. Anyway, it is chosen. If I choose 1, then what does that mean? So 1 unaccepted connections is allowed. Okay, that's fine. Okay.
Do you have to import SockStream? Do you do like from
SockStream is a variable. I mean, it's a value, not variable, value. Already, when I import all the modules from socket package, then that value is imported and available to use. And then I want to see the data and address Find the listen. No. I need to do more. After I do listen, then s.accept. Right? I need to accept. When I do accept, then it returns two things. Connect and then remote host, remote port, and then we can say here print connected by, and then string remote host, and string remote port. I want to make this simple. Remote, say, rather than remote, I can say R host and R port. Therefore, here is R host and R port. Okay. And at the end, that con should be closed. But let's not close. Leave it open.
You need two parentheses on the end.
That's right, we need one more. Thank you. Oops. And then we can save it. Save where? Save Morrissey 505 in class. Then I can call it server.py, server. Okay.
What did you say, guys?
Server. Server.py. I can create one more program by pressing Ctrl N. I'm going to copy this to that client side, but something that we don't need to listen. We do not need to bind this specifically, but bind and that all together can be done. Wait a minute, do I have a connect? We have an access, right? So we have a connect here. So that instead of that, we need to do here connect. s dot connect. Here we can say connect localhost, because we do not know the IP address, but nickname is localhost. And then we want to connect the port number 54321. So what you need to do is you need to, let's try to execute it. So server should be executed first. So execute. It should be one argument. So put that in parentheses. If you do that, then it says firewall. So we have to allow except. So server is running here, right? And then you can also execute to client.
I'm just getting socket is not defined on line 3. I don't know why.
Which one? Server?
Yeah. On that one, yeah.
You need to put have double parentheses. Did you put
Yeah,
that
I
double?
changed that. I'm getting line 3. S equals socket is not defined.
This?
Yeah.
Although you do from socket import everything?
Yeah. That's a star, right? Yeah.
Mm-hmm.
I got that. It's really weird, right? I'm using live clips though.
No. Let's try something else first.
Why is it
Right now,
so the normally permitted?
so you have to permit.
I think the allow, right? It's allow.
Yeah, should allow.
I think
Yeah. And right now, thing is this: we have only one window, right? So we don't see much. So what I want to do, I want to close this. I want to interrupt. I want to terminate. I want to restart. Okay. So this editor, I leave it as is. And then I want to run the command line windows, like this command line windows. How can you get the command line windows? You can get by pressing Windows button and pressing Windows button. I'm holding down Windows button and press R button. R for run. There you need to. Let me show you. If you do that, then you will have this came up, right? There you put a CMD for command, and OK, then you will have another Windows came up. So I wanted to have 2 windows at least. Okay. And go to the place that you save yours. So I can go to
my location. Make sure that if I have a server.py, I have a server.py, I have a client.py. So what I'm going to do is I'm going to run server on this terminal while I'm going to client on another terminal. So I need to do also so I have wait a minute. Okay. I have a client here, right? So what I'm going to do here, I'm going to run Python program, Python engine and Python, run the program server.py, then my server is running. See, it doesn't do anything, but it is running. And then similarly, at the client side, I can do Python 36, Python, and then client. Okay. Here, object like, string. So what we need to fix here is that I need to send it to binary format. So rerun this and rerun the client. So client works perfectly fine, right? But we do not know how's it going on. But there is no error. But this guy says, the server says, connected by 127.0.0.1, and the IP and the port number this guy used is automatically assigned. That is 59644. Okay?
Professor, what's the B means before
B-
the
It's a binary. I want to change it to binary.
Okay. So what we need to do is to, at the server side, I want to return, so that at the client side, we need to see if it is really arrived at the server side and returned back, right? So the way that we need to do is send. So connect con.send is data. Wait a minute. So we need to first receive. Here, before we print, data is received from con.receive from no, I'm going to simply to receive. Receive 1024. Okay. And then I want to return that data uppercase. Function. send it back to. Okay, and at the the client side, client also receive it, right? So client receives receive 1024. I'm going to call it data, and I'm going to print it here. Print received from the server is data. If I don't do, then let's try what happens and save it. So redo, server is running, and client send out, and then see here, I sent out a small hello Mercy, right? But it sent back, it sent to the server, so server acknowledge it, connected by this another port, right? At every time, because I didn't bind for the client, so client, the network manager operating system assigned the port to the designated server ports. So server receives it and then repeat that port number and change the message to uppercase and send it back. So hello Mercy will be, this is what I made, right? If I don't do this, say encode and data decode, that should work. Server is running and client is running. What I want you to do, a little more things. At the server side, you can send not only that, I can here print message from client, and then I can say data decode, and here I can say when I send, I want to send thank you. So what it does is that at the server side, server receives the data from the client and then decode it, because at the client side, initially encode it, right? So at the server side, we decode it and print it. And then we also my message, server message, by saying thank you, that is encoded, and send back to the client together with the case change. The exact same data that receives, but the case changed. Let's see if it works. I want to make a new line. New line. We'll see if it works. On the other hand, the client side, once hello Mercy message sent to the server, and then we can say, oh, that has been okay, and then we receive data from the server, and we call it data, and then we saved it. Oh, this is what we done already, right? So let's try. So run the server. Server is listening. Keep listening. Client. Okay. Integer is required. Something like this. Integers are required. Oh, comma is not really. Okay. The other way that we could do is with data, and we construct the data. And then send with data, return data. Okay. The server is running and listening, and client trying to access. So here, connect message from client is hello Mercy. That is sent, right? But at the server side, we change it to uppercase and then add more message to the client. So received from the server is thank you, hello Mercy. Right? So I'm trying to do here. Let's see if it works. I'm not sure because of network. New line. It's not delivered, right? Cannot byte the string. Yeah. This is not working. Is it working in this way? Oh yeah, that works. So if we encode it, then it works. Thank you, and next line, hello Mercy.
Okay, here's what I want you to do. Right now, server and clients, one-time communication. Okay? And the message is hard-coded. So can you get the message from the user and send the message to the server and return the uppercase the message?
So let's try first get the message not hard-coded, but we want to get it from user. So what we want to do is send me an input, enter your message and wait. And then the send me is encoded and to be sent out. Okay. Simple change at the client side, so more user interactive. So when you do this, then it says enter your message. So what do you want to do? Is Ellen there? Then it says thank you.
Didn't say Ellen's presence, but because it is not intelligent. You can put some intelligence at the server side. And run. I need to see where, if we run, let me find out. And up here. Come here. When I run Python, Paizo, there's a tricky. If you run IDE, integrated desktop editor, like IDE, like Paizo, then without knowing specifics, you still run very nicely. But it doesn't run all 100% possible cases like this. If you want to open up 2 or more shells, then Paizo shows only one shell. So we don't see how client is running. So in that case, we need to go back to the primitive level, which is run everything on command line, open up new terminals. But to open up new terminal even, we need to see, for example, how that Paizo runs, therefore, hold on, let me find out. Paizo, where did I save? Oh, here, Paizo. I need to find out. Paizo is somehow mingled. Oh, that is the issue. Here is what I found so far. I may be wrong, but presumably when you run Paizo, then Paizo mingled all the environment together. So it is very convenient, but it doesn't support all possible scenarios. Scenario that we have here is we want to have multiple clients and one server. Then each such will be a shell, right? But Paizo provides you one shell. So when you run server on Paizo, then it runs server shell well. But there is no way that you can see the client shell. So best way is that that you need to have you need to run Python from Python native Python packages. Native Python package means you have to download it from. Let's work together. So here you can download, for example, Python download. Then you can see here www.python.org download. Okay. Then I wanted to download Python 3.5.2. Then it is downloaded, right? It takes 1 minute left, 2 minutes. How come it increased?
Yeah, should we do it here or wait till we get home? It might be slow. Yeah.
I'm introducing you, so you have to, yeah. Right. And then come here, downloads. There's a Python, right? You simply double click it and install it. If it installs, likelihood it is installed program files, one of those. But in my case, I think program files. Then, the one that I did was I installed it on top. Okay, you can specify on your own. So in my case, I specified I have an old version Python and new version Python 3.6. Under this, I have a Python. This is a program that I want to run. Remember that. Therefore, when I run Python, I specify explicitly C:\Python 3.6 Python. This is the Python interpreter, and then space followed by my program, which is client.py. In that way, you can run multiple Python shells at the same time. I don't do that, but another way that you could do is you can set the path. Once you set the path, then you have no freedom because always it runs. Therefore, I didn't set. But in your case, if you want to set, and therefore Python runs all the time at that place, then here is what you can do. I don't know here, but if you type Windows button and home, what is this? Oh, here. Yeah, my PC, and then property. Go to my PC and properties. Then you will have this, and then click advanced system setting.
then you will have this. And then click on environment variable. At your user variable, if you do not have a path, then you create new and then type uppercase PATH and then variable here. But if you have already path, then edit. Okay? And then at the end of this, where there, what you need to do is go back to, not this, go back to your, for example, in my case, I'm not sure if I have that, but apps data is not shown usually. I do not know why, but usually it's not shown. And here, and programs, and common, I don't have any. But in your case, go to the place where there is a Python. So in my case, my Python is where? Here. So Python 36. Then I have a Python this, right? So where there is a Python, there's a directory. This is a directory, right? So this directory needs to be Control-C, copy, and come back to here. This is a path. So at the end, don't forget to put a semicolon. That is a delimiter. At the end, you have to append. Okay? I do not append that, but append it, and then click OK. Okay? Here also click OK, but I'm cancel. And click OK. Then your path is set. After that, you have to reopen the terminal. Because this Windows command terminal knows the previous path. Okay? So you have to reopen it after you set the variables. Reopen it. And here you type Python, simply Python. Go to place where you have your program. For example, like this. Then make sure that you have your program, server and client. There, you simply type Python. Then this Python is the Python that I set as a default. Probably that is a different version. Let me see what is the version that I set. There's a 3.5.2. When I ran previously, it is a 3.6, which is a beta version, but still okay. So here is simply Python and server.py. That server is running, and here Python, because the Python is recognized by the system variable that we set, right? And then client.py, then client is running. So then here we say here is how the environmental variables set so we can run, enter, then
Do we change the system variables or the user variables?
Doesn't matter. Doesn't matter if you have a multiple users, so that if you want to make that path to everyone, then you can set it up the system variable.
Oh, okay.
But if you are the only one using, then user variable.
So we're adding that you got to the path part, and then we add that on, on the end there. I'm seeing that you can do browse directory or browse file. Here, I went to browse file, and then it brought me to this, where it showed me, it put it in
so
there.
at the end, don't forget to type semicolon. Please, this is recorded. If you do not understand what I explained, keep listen, step by step. and practice. Unless you do, then the skill that I just showed to you is not going to be your skill. So you practice it. Okay, this is, once you know, this is very simple. I mean, many cases we start from this, and after this we program. Okay, you need to understand the whole structure of work environment. Otherwise, although you are working, you do not know where you are. You simply know a small world if you jump into that area. You need to understand the whole environment of your computer so that whichever comes onto your mission, then you could do. Okay? Not just being relied on presetting. Okay? You can reset and you can redo everything. So after lobby, please, I'm going to post this on weekend. So open up. Is it being recorded? Yeah. Open up and listen one sentence and practice and coming back and do that. Unless you do. That's what I'm saying. Environment. I showed it to you, all recorded. Although I did it fast. I don't do that here for another 3-hour lecture, which is unrelated with this topic.
Can you go back to the Paizo on the compliance script on there?
Paizo, okay.
Yeah. So if I try to look at it at the video later on the weekend,
Yeah.
it's really hard to see because like the
You want to?
letters are really like kind of
Where is mouse?
focused.
Okay.
The resolution is only like 480.
Yeah, this is a server, and this is a client. This is recorded. So when you play this, it is there. Server and this. This is not. Let me close this. Server and this. After lobby. Replay. It's going to be at the end of the video clips, so you own this.
So my main thing is I just have to download Python. That's what I have.
You already downloaded it.
Okay.
Now, only what you need to do is 2 ways. Every time when you run, you need to fully specify the path, the way that I specify here. For example, this is fully specified from C:\/ all the way to where there is a Python space, and then I run my program. You could do that. I didn't set this new version 3.6. Okay? But you already installed it. Although it is very long, but anyway, that is there. You specify all the paths till Python program, and then make one space or two or more, and then put your Python file name, then it runs. Okay, that is one way. Another way is that if you, in your case, when I see yours, it's very long, right? It's highly likely every time you miss spell, then you can get to that Python. So you have to go to that place. Go to that place it here. Okay, wherever there is a Python, then up here, address box, you highlight it, copy, and back to your environment setting, the path expression.
Yeah.
At the end, you put semicolon and paste it and save it. Okay button all the
If you
way.
kept it in C, like yours is in the C drive, right?
Mm-hmm.
So when you just, like, your path was just C and then Python 3.6, right?
Mm-hmm.
So the difference is ours is in.
That it doesn't matter.
Yeah,
If it is a E drive, then
Yeah.
it should do.
This is very trivial. I know we should have this, you're right. But now, because I have live clips, can I still now try to run these? Like, even though I'm getting the socket.
Eclipse or Piezo, the problem for our program, and Asaki programming, is that they provide only one shell. But we need to have 2 or more shells. One shell for server and 1 or more shells for clients.
Okay.
So next week what we will do is we open up one server shell and multiple client. So multiple clients wants to enter
Server.
to server,
Right.
and what case we need to see in what points there is a denial of service.